I was watching this thing. It was like talking about myths of space, and of course the really big one is the absolute zero factor. It's like not actually absolute zero in space. It's a few degrees warmer than that. I mean, a few degrees warmer in Kelvin. And Kelvin, of course, is, just a different scale.
Oh yeah.
It starts at like, what is it, 273 degrees. Kelvin is 0 degrees centigrade.
Yeah, those conversions make no sense. Like,
Kelvin
conceptually.
does. Well, Kelvin does when you're doing, physics.
Yeah, when you're doing it, but I'm saying in the sense of.
Well, Kelvin makes sense in terms of photography, because you want to balance the light so that colors turn out correctly when you're processing your photos later or when you're doing video. But that doesn't matter. Like, if I said something is 5,000 Kelvin, I'm probably talking about my light bulb. If I say it's 3,200 Kelvin, I'm talking about that light bulb.
Yeah.
That's like, I mean, right now the sun, the quality of light from the sun is about 5,000 Kelvin, because it's pretty white out there. It's like bright white light. I can't see any like real tone of anything because it's so bright. But we know that the sun is outputting a full spectrum of light and radiation, like a really broad range of electromagnetic energy.
Yeah.
I mean, we lack the sensors to fully read like the upper end of what's.
Well, and that's kind of what I mean in the sense of those conversions make no sense, where as humans we can only really perceive such a small range, like,
oh yeah,
of what temperature extremes really are.
Yeah.
So to us, when we're trying to fathom these things, it's like what we can perceive is, I imagine our nerve endings stop working at about, negative, maybe 100. I don't even think that be that much. Maybe negative 50 degrees Fahrenheit.
When I was a child, I went outside. It had negative 40-degree weather, and I couldn't tell that it was cold.
Yeah. See, so there you go. That's a perfect example.
Incidentally, that's also the threshold where Fahrenheit and centigrade are the same.
Yeah.
But the scale's so skewed that once you go below negative 40 in Fahrenheit, it's like negative 45 is colder than negative 45 in centigrade or something like that.
Huh. Yeah, it makes no sense.
Yeah, and Fahrenheit just stops because it reaches 0 Kelvin, and you can't actually go past.
Because then to base centigrade off of boiling water effectively, which it seems to be the base
at 1 atmosphere of pressure.
Yeah, that's gonna have its limits.
But it's gonna change once our atmospheric pressure changes.
Absolutely.
And once that happens, that means that the Schumann resonance changes. Oh, so have you been following the North Pole, the magnetic north shift? So for the past few months, I've been watching this heat map of magnetic influence around various points on the globe, and these are all being monitored with these research stations. And for a while there was a spike in Canada, and it started shifting, and then now the Siberian one or the Serbian one was going crazy.
Mm-hmm.
And then there's another one like further east, and it was also going crazy. And you can scan back through the months. I may have sent you the link, or I may have talked about it and forgotten to send you the link. I'll send you the link. But it's I've been watching this.
Mm-hmm.
I have no idea what to make of it, because I just started paying attention. A buddy of mine was like, "Hey, you might be interested in this," and because he sent me a spectrograph. And this is like a full range down to like, decimals of hertz of activity up to, whatever the Earth is actually interested in. So like 8 kilohertz. It's not that much. The Earth doesn't really shake that much more. And this resonance is a very low resonance. It's like 6 to 7 hertz. And maybe a little lower. Maybe down to like 3 occasionally if the top of the ionosphere is collapsed a little bit, because occasionally we're oval shaped. But yeah,
I'd be interested to see how that correlates with solar activity
or planetary bodies.
I mean, I think planetary bodies might influence it, but because the sun is like constantly bombarding us with
That's true.
um, particles, like in different proportions, the radiation is going to be drastically different in the sense of, you know, are these happening on days where there's auroras?
Yeah, what's the Van Allen belt activity look like today?
Exactly, those types of things. Where is it? Which direction is that magnetic shift coming from? Is it coming from inside or from outside?
It's from the inside of the planet that it's moving.
Well,
that they think.
That's what I'm saying. Because they would assume, if they're not looking at all these correlating factors, and there may be something that's pulling it from or causing it to shift from the sun. Is what I'm saying.
They've got like 8 research sites around the planet that are like supposed to. I don't know. They're supposed to.
But what I'm saying is, those are measuring one thing. I mean, not one thing, but they're measuring the spectral shifts in the planets, like.
It could be related to the sun, is what you're
right.
saying. Sure.
And because what I'm saying is, when you get that data set from what they're measuring, there's a complete different data set of things that are measuring the same thing for the sun, but those two things aren't being checked against each other at any given point necessarily.
Yeah.
Like, if someone was like, oh, I'm going to study these things, then they would have to do that, but those two data sets aren't being checked against each other.
Yeah, like, we can't assume that they're interrelated at all at this point, because only one is definitely about the geoplanetary resonance.
Right, and that's what I mean, in the sense of there's still so many theories about, like, they have spectral readouts of what is at the core of the planet, but they don't know how it's put together to say if it's molten or if it's hard or
the spinning ball of metal.
Right. I mean, you know, because a spinning ball of molten metal is going to be different than a spinning ball of
liquid metal.
Yeah. That's or a spinning ball of like solid metal.
At the core of our planet is a spinning ball of vibranium.
Right. I mean, that's very possible.